The first part of this lesson is expanded notation with exponents. All that to say, how would I find the expanded notation of this number? Yes, Isaac?
3 times 100.
3 times 100
60 times 10.
plus
10 times 6.
6 times 10
6 times 10.
plus
5 times
5 times 1. Does everybody in this class know how to do this?
1. Yes.
Okay, just making sure because we're fixing to take it one step. Okay, when you're working with exponents, okay, is it fair to say that this 100 is the same thing as 10 times 10? Is 110
Yes.
times 10? So would it also be fair for me to say it's 10 squared?
Yes. Yes.
Yes. Okay, because 10 squared is 10 times 10, which is 100. Okay, an easier way to look at it is we're trying to put this in using exponents. So they're wanting us to get rid of all these zeros, basically. So what you're going to do is you're going to go 3 times 10, and however many zeros there are is what you'll put at the top. Okay? But if you're thinking about what makes sense, 100 is 10 times 10, which is 10 to the second power. Does everybody understand that part, what I'm saying?
So how many zeros? Just how many zeros with the exponent on them?
Yes, you're exactly right.
I'm
So
really
because
confused.
this, huh?
I don't.
Okay, so
there-
basically I'm trying to learn to write this like that. That's the whole reason I'm learning how to make these into exponents, okay? And how I got this, there's 2 ways to look at it. One, you can go, okay, I have 2 zeros, so that means I'm going to have a 2 right there. Or 100 means 10 times 10, which is 10 to the second power, because 10 to the second power means 10 times 10. Everybody understand?
Yeah.
Everybody's good, yes.
If you had like 6 times 1,000, would you do?
Okay, let's pretend like we
10
said
cubed.
4,365. I would take and go 4 times 1,000, right? Everybody gets that? Which would really be 4 times 10, and how many zeros do we have?
3.
3, which really means 10 times 10 times 10 equals 1,000, which is 10 to the third. So there's a shortcut you can take and just count your zeros to get the answer. But the explanation way is that 1,000 is 10 times 10 times 10, which is 10 to the third, which is why I put that there. But if you're wanting to move fast and not use the explanation way, you can just count how many zeros and put your answer right there. Got it? Sort of? Yes.
Will they ask us to write that?
They will say, the question they will tell you to use is, write this in expanded notation using exponents. So we're putting it in expanded notation, and then we're making it using exponents, not using numbers. Got it? Sort of?
Well, you have to use numbers on some of them, like the 10.
Not using big numbers. Kind of. Okay? These are, yes. Yes. Okay, so this would be the answer to that, right? Plus, how would I do this one? Somebody help me. 3 times 10 to the second power. They understand?
Yes.
One of y'all help me on this one. 6 times 10 to the first power. Why? There's 1 0.
You have to put them in the first power. Like that.
Do just like that. And then, this is really going to flip y'all out. 5 times 10,
Is it 0 back?
0. Whoops. Now, because guess what? There are no 10s. There's nothing 10 times 10. There's not even a 10 to multiply. So there's 0 10s to multiply.
It looks like degrees.
Okay? And 10,
Is that all we do for it?
yep. And 10 to the 0 power equals 1, basically, which is what we're saying. Okay? Now, help me out. That's just one number, okay? So let's try another one that they're going to give you. For example, this one says the speed of light is 186,000 miles per second. My Atlanta, that is really fast. Okay? The speed of light is about 186,000 miles per second. Write this in expanded notation using exponents. Ready? Let's first write it in expanded notation, then we'll use exponents. Help me write it in expanded notation. I take my 1 and I tell you what place it's in. Ones, tens, hundreds, thousands, 10,000s, 100,000. So guess what I multiply it by? 100,000. Everybody understands that concept. The 1 is in the 100,000 place. So I'm basically saying 1 times 100,000. Everybody understand? Plus, take my number 8. I'm done with that one. Take my number 8, and it is in the 1, 10, 100,000, 10,000. So I'm going to put 10,000. Right? Help me out with the next one. Somebody. 6,000 times
1,000.
1,000. Why? Because it's in the thousand spot. 1, 10, 100, 1,000. What do I do with those zeros? Nothing. They have no value. Okay? Now if I had 0, 0, 5, I would finish it out and put plus 5 times 1. Okay? Because it will be in the ones place. Alright, now that we've got it in expanded notation, I'm going to write it using exponents. You help me out. Eliza. 1 times 10. That's how you write scientific notation. 1 times 10. Now what power is it going to be? How many zeros I got? 1, 2, 3, 4, 5. 5. Pretty simple, right? Okay? Now, let's do the next one. 8 times 10 to the Isaac. 4. 1, 2, 3, 4.
What is 4 called? Because like 2 is squared.
Fourth power.
Oh.
Everything else you say fourth power, fifth power, sixth power, seventh power. Okay? Plus 6 times 10 to the Jaden. Third power. And that is your answer. Does everybody feel like they understand? So this you already knew how to do. You should have at this point. And now, honestly, we've made it so simple that you just count the zeros. We don't have to figure out how many times 10 times 10 times 10 times 10 times 10 equals 100,000. I just know that it has 1, 2, 3, 4, 5 zeros in it. Yes?
So we wouldn't write like 0 times 10. We wouldn't add the zeros. We'd only do the...
You just put 1 times 10, 6 times 10, 5 times 10.
So we don't put those last 3 zeros times 10.
Nope.
Okay.
No, this is the whole thing, 100,000. So it's 10 to the 5th power, which means 10 times 10 times 10 times 10 times 10, which is 100,000. Got it?
He's talking about the end zeros, the 3 zeros at the very end.
Oh, thank you. A little slow. Got it? Okay. So 0, 0, 0, no. You don't do anything because they have no value. Like I said, sometimes they'll have a 5 at the end and these will be zeros. You will still have to do this one. And so we would have went 5 times 1 because it's the first one. And what would I do for this? 10 to the 0. So I would go plus 5 times 10, and there are no 10s, it's just a 1.
I'm not really confused about this, but I'm just wondering why it's like this. Wouldn't 10 to the 0 power be like 0, 0?
I know, it sounds really weird, but it's actually 1.
Yeah.
Anything to the 0 power is 1. You'll learn that in 8th grade. Yes?
If that was a 5 to the times 10 to the 0 power, would 6 times 10, would that be your second power? No.
This one? No, because there's 3. We're skipping 2. So this would be 1 times 10 to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0. See how that worked out? It's a progression all the way from 0 all the way up. Understand? Okay. Now we get to go to the second part of this lesson. Kill us.
Oh
Okay?
wow, a second part.
I know, right? Okay, so now this is second part 292, and it's a totally different lesson. Have y'all heard me talk about, please excuse my dear Aunt Sally?
Yes.
We're doing that in a deeper way today. So it's called order of operations. What order are we doing the operations? Not an actual operation, okay? But order of mathematic operations. PEMDAS. So everybody write down PEMDAS at the top. PEMDAS, which means please excuse my dear Aunt Sally. Who remembers some of the points that I made about this? Yes.
Sometimes it can be head,
Yes?
pizza,
Okay. So who remembers what I put underneath these?
arrows.
Arrows. Why are the arrows there?
They can be switched.
Yes, I could actually divide first and then multiply, or I could actually subtract first and then add. Whichever one comes first, left to right. Everybody understands that? So if I'm reading my problem from left to right, if I had a subtraction first, I would do it and then add. Okay? So I'm going to put a line right here and a line right here. Okay? Because they kind of go hand in hand. I need to complete all my multiplication and division first before I move to adding and subtracting. Yes?
Is the reason they put the arrows separate because you have to multiply and divide
First, and then add or subtract.
Okay.
That's kind of why I'm putting these lines here too. I have to do this first before I can do this. Yes?
Why did the person that created this, why did they make it so that you have to do it in a certain order?
I don't know. I'm just glad they came out with this acronym because I would have a hard time remembering what you're supposed to do first. Now I wouldn't because I've taught it for 7 years or whatever. But okay, so ready? Here's one of the problems you're going to get. Okay, don't freak out. 5 minus 8 plus 8 divided by square root of 16 plus 3 squared times 2. Woo!
Ooh, can you give me a problem like that except it had square roots in it and I could do it?
Good job. Okay, so here's my problem. Okay, I'm going to make this a times right here, like that instead of the X, just because I think it looks better. Okay, that totally flips everybody out, doesn't it? What in the world am I going to do? Okay, my very first step is what? Parentheses. Are there any parentheses problems?
Yes.
Yes. So watch what I'm going to do. Which one is my parentheses problem?
8 plus 8.
8 plus 8. This is my very first thing I'm going to do. Why? Because PEMDAS told me to. 8 plus 8 is?
16.
Because I'm writing on the board, I'm just going to erase it. This 8 plus 8 and put a 16 in there. But what I want you to do is answer your question 16, bring everything else down. So this, I still haven't done anything with minus or 5. Bring divided down, square root of 16 plus 3 squared times 2. Everybody see what I did? I brought everything else down. I just answered this problem and put it in there. Got it? Do I have any more parentheses?
Nope.
Nope. It's done. Any exponents?
Yes.
Yes. Going left to right, do you see any exponents?
Yes, 3 squared.
Okay. There's one thing else that I wish they would kind of said, but exponents can also include square roots. Okay, because exponents are the opposite of square roots. 5 squared is 25. Square root of 25 is 5.
Oh.
See what I'm saying? They're opposites. It's kind of like adding and subtracting. Square and square roots are opposites. 5 squared, 25. Square root of 25, 5. Everybody understand what I'm saying? They're opposites. So, do you see any square roots or exponents? Yes. Going from left to right, what do you see? I see this square root. So, what is the square root of 16?
4.
4. So, if I were you, I would put a 4 here, bring everything else down, but I'm just going to erase it because it's easier for me on this board to do that. Everybody see what I did? All I did is change square root of 16 to 4. Square root of 16 means what number times what number? The same number equals 16. So we got 4. Any more exponents or square roots? Exponents, right here. 3 squared means, don't tell me 6. 9. 3 times 3. 3 squared means 3 times 3. So I'm going to put 9. Okay, everybody see what I've done so far? All right, we're done with this. Now multiplying or divide left to right. Does anybody see a multiplication or a division going from left to right? 16 divided by 4. What is 16 divided by 4? 4. So I'm going to erase that and put a 4 there. That's my answer. Anybody else see any more multiplication or division going from left to 9 times 2? 18. I'll erase that and put that there. Everybody staying with me so far? Okay? Now, done with that, done with that. Now I'm going to add or subtract left to right. Ready? 5 minus 4? 1. 1 plus 18? 19. You should have gotten the answer 19 on that problem. Good? Those are actually fun to do if you waste paper. Everybody know what I mean by that? Do not try to conserve paper and think, oh, I can do 6 of them at once. Don't. Yes, use all the paper you need.
Looks like a cone.
Okay, ready? Listen, watch this. 2/3 squared. What in the world does that mean? What does this mean? 5 times 5 equals 25. What does this mean? 2/3 times 2/3. Still means the same thing. I would take this and go 5 times 5. I would take this and go 2/3 times 2/3.
4/9.
So the answer is 4/9. 2 times 2 is 4. 3 times 3 is 9. Got it? You're just taking that number and multiplying it that many times. I know it's a fraction, so it's a different type of number, okay? So 2/3 times 2/3 equals 4/9. Everybody understand? Whew, and we don't even have time for a break or anything. It's time to go. And you need help. I'm so glad you do. But of course, today is one of those days where we do not have time. Please go home and